Not yet, because these two still need to take it. Depends on what you mean by pass, but the average was not high.
Oh.
Yeah. Lowest I've ever seen in my 1 month of teaching.
What was it? You said
Well, before you two, maybe you guys can bring it up. But the average was a 73%.
What?
Well, that's because we didn't take it.
Oh yeah. I'm sure that's the reason why.
What was the highest grade? Was 100?
No hundreds. Yeah.
What's the lowest grade?
I'm not saying the lowest grade.
Above or below 10%?
The lowest grade was above 20%.
Wait, can you tell me
What?
I can tell you after. I'm not. I don't want to broadcast people's grades. It's okay. All right. So some comments from the quiz, without actually talking about the actual questions of the quiz, obviously. The notation is very important. So I took off 10% of the points of each question if you had the wrong notation for the limits, which is not a lot, right? I took off 0.1 points out of 1 point.
How kind.
Yeah, I'm sure Mrs. Lee probably took off more, so be thankful. Okay, so just a review of proper limit notation. Let's maybe I'll show you guys an example. Let's say we have the limit as x approaches 0 of square root of x plus 2 minus square root of 2 all over x.
0, 0.
Yeah, so when we plug in 0, we know it's 0 over 0, so we know we have to do something. In this case, we have to rationalize the numerator, right? So we multiply top and bottom by this. Good. Okay, now what's very important is that you keep writing the limit symbol.
Yes.
So if you had only written, x minus 2, sorry, this is totally wrong. Nobody caught my mistake. If you had only written this, which is correct, but the notation is wrong, right? You dropped the limit too early.
No, its limit is x approaching 0.
Okay? If you wrote that, you would have lost 0.1 points. What you need to keep having the limit, basically, whenever the x's are still in there. Okay? As a general rule, if you still see x's in your expression, the limit symbol should still be there. But once the x's drop out and you plug in stuff, then you don't need to have the limit symbol anymore. Make sense? So we're going to keep writing. We have to keep writing the limit symbol because we still have x's in the expression. Okay, the stuff cancels out. Very good. And we're left with limit as x approaches 0 of 1 over square root of x plus 2 plus square root of 2. Okay, now I'm going to plug in x equals 0. And now I have to drop the limit symbol.
1 over 2.
No. So now I have 1 over square root of 0 plus 2 plus square root of 2. Okay, notice how I dropped the limit symbol because I've started to plug in my value for x, right? If you had kept writing it, you would also lose 0.1 points. So if you had kept writing the limit symbol, even after you plug it in, you would lose points.
Are you serious?
Yep.
Wait, when do you drop the limit?
You drop the limit when you plug it in.
When you plug it in.
Yes.
I know you did.
So you're left with 1 over 2 square root of 2 equals root 2 over 4. Questions?
What? The square root of 2 plus square root of 2 is square root of 4.
No. Sorry.
Wait, how do you...
Square root of 2 plus square root of 2 is 2 times square root of 2, right? And then I rationalize the denominator by multiplying by root 2 over 2.
What if you left it at 1 over 2 over 2?
I would take off a small amount of points. Although the test is multiple choice, right? So you would presumably figure it out.
How many questions?
He wants to rationalize it.
Mm-hmm. What would you say?
Oh, I was just going to say, great job.
Oh, thank you. Anson?
Okay, when's the first?
I'm
Give me 2 weeks.
not sure actually. Yeah, I only have one period of this class, so I'm not super on top of things.
It's okay.
We do one more
One more what?
question like this, but different example, different 0 over 0.
We'll do some more later. But
We take
I,
quiz next.
huh? You can come to my office hours and do it.
What is your office name?
It's on Moodle. It's a pretty complicated schedule, so I can't rehearse it now. Okay, I wanted to go over some more of those trig limit things because there is one question on the test that I didn't teach you guys that much about, I guess. So let me do that quickly. Okay, so just to review, the two limits that we need to know are the limit as x approaches 0 of sine x over x equals 1. And second, limit as x approaches 0 of 1 minus cosine x over x equals 0. Okay? Don't mix them up. That would be bad. Okay, just to clarify, this is not actually equal to 1. It's the limit that equals 1. It's the limit as x approaches 0 that makes it equal to 1. Okay, so for example, if we had, this is an easy one, limit as x approaches 0 of 3 times 1 minus cosine x over 4x, then in order to solve this, we would take out the 3/4, bring it to the outside. That's allowed for limits. And then inside the limit, all we're left with is, 0. 1 minus cosine x over x as x approaches 0. And so that's 3 over 4 times 0 equals 0. Pretty easy.
That's for which one? The right one?
What? I'm doing a new problem here. Yeah. These are the things that we were supposed to memorize. Okay? So that's one example. You can watch the YouTube video later. Yeah. Okay, second one. Let's say we have the limit as x approaches 0 of sine x over 5x. Okay? What's a kind of analogous first step? Yeah, very good. Taking the 1/5 out. Sine x over x. And that's 1, right? The limit? So that's 1/5 times 1.
Wait, how is it 1? It's because sine x was sine.
Yeah, this limit that we know as 1. So then we're left with 1/5. Okay? So those are stuff we have already covered. But there is one slightly more tricky one that we haven't covered. But it uses the same equations, but it's a little more tricky. And that is this one. Okay, for example, sine of 5x over x. Okay, this is more tricky because we can't actually take the 5 out of the limit because it's inside the sign, right? We can't just take it out. And so for this, there are different ways to think about it. Personally, what I think is the most straightforward is by making a substitution. We write y equals 5x. And if y equals 5x, then x equals y over 5, right? We make a substitution, y equals 5x. And this will make it more similar to what we have already, okay? Similar to the ones that we know already. That sine x over x equals 1 for the limit as x approaches 0.
What is y?
I'm just making a substitution. Y is just another variable. Okay? So I'm using kind of like a dummy variable. I think that's what they call it. And I'm using this dummy variable to make it more pleasant to me. Okay? So this is going to become the limit now as y approaches 0 of sine of not 5x but y, sine of y over y over 5. Okay? All I did was make these two substitutions. Okay? And now, if I simplify this fraction on the right side, this leaves me with 5 times sine of y over y. This was not on the quiz. Yeah, which is why I want to go over it for the test, because it's on the test. And so now I have a limit in terms of y, but now I have sine y over y. Okay, and so I know that this is 5 times 1, which is 5. Okay? So this would be an example of the kind of work that you need to show for this kind of problem. It's not as simple as just taking it out of the limit, because the 5 in this case is within the sign, right? You can't just take it out.
Aren't you dividing by 0 when you plug it in? When you plug it in, wouldn't it be?
That's right. That's why I need to use the limit. That's why I need to use what I have here. The limit as x approaches 0 of sine x over x is 1. Audrey? Haven't decided that yet.
So what?
I don't know yet. Just whatever Miss Lee. Okay, any questions?
You scroll back up to the thing that's boxed real quick.
Yeah. Those are the two trig limit identities you need to know for the test. And so basically the goal of, these problems is we just want to rewrite it in terms of something that we know already. Okay? So whether that's taking out a factor of 3/4 or 1/5, we're trying to rewrite it in terms of something that we already know, which is these two things. And in this case, the way we do that is by making a substitution, y equals 5x. Okay? Okay, now you guys can do an example problem. Just saying this one is very similar to what's on the test, so, I would really do it. Hopefully it's not identical. That'll be bad, but... Okay, the limit as x approaches 0 of sine 3x over 2x. Okay, so try to do this by making a substitution, such as y equals 3x. See what you get. I don't think so. Oh, also, Tristan, you're switching seats with Brock.
Wait, so I got y's equal to 3x, then what?
You make that substitution. Okay, so we're going to make the substitution y equals 3x.
Yep.
And then what is x in terms of y, though? That's the second thing.
X in terms of y is 3 over y, right? Or y over 3.
Yep, 1/3 y.
Oh, and then you plug it in, right? So sine,
Yep, and then you try to rewrite the whole thing in terms of y.
oh, so sine y
Yes.
over 3. Y over
Nope.
3.
Does anybody else have a correct answer? Yes, I agree with that one.
What was it?
3 over 2. Okay, I'll do it. So we're going to make these two substitutions. First, y equals 3x. And if we solve that for x in terms of y instead, that gives us x equals y over 3, right? So we're going to plug that in, and now it becomes a limit as y approaches 0 of sine of y, right? Because 3x is y. We just made this substitution. And then on the bottom, x is equal to y over 3, right? So this bottom thing becomes 2y divided by 3. Okay?
Would you not have to multiply the 2 out to the y times y over 3? So it would be 2y over 6.
No. X is y over 3, right? So 2 times y over 3 is 2y over 3.
It would be 2 times x and y over 3. Oh, wouldn't it be 2 over 3?
I'll show you. X is y over 3, so...
Maybe 2y over 6.
Okay.
2y.
Yeah, fractions are hard. But this becomes sine y over... It actually becomes 3 sine y over 2y. because the 3,
Comes up.
yes, because it's a thing in the denominator. It's a denominator in the denominator, so it becomes a numerator.
Y over Y.
Right? Yep. So then we can now take out the 3/2, and then we're left with the limit as y approaches 0 of sine y over y, which is 1. Okay? This is the work that you have to show. But if you forget all of that, you know, the kind of trick is just, you know, it's just 3 over 2. But you'll lose points for not showing work. But if you're really stuck, just remember that trick. And you can at least get some points for getting the right answer. Okay? But this, you do need to show the work. Questions?
Just so you can like check it.
No, so you can get the credit for showing work. It's just how fractions work. Sorry, don't really know how to explain that. It's
2 just multiplies to the top, so just to the y.
yeah, like when you divide by a fraction, it's essentially equivalent to multiplying by its reciprocal, I guess.
Oh, I didn't see the fraction.
So, you know, this is essentially sine y times not 2y over 3, but 3 over 2y. Yeah. Okay, any other questions?
So when you like plug in the y, you make it y is approaching 0 instead of x.
Yeah, that's right. Yeah. Questions? Okay, then let's go into actual topic for today, which is infinite limits and vertical asymptotes. Okay, so infinite limits actually don't exist, but they're just a helpful way of writing limits that don't exist and go to infinity. Okay, so it's most instructive to go through a quick example. Let's say we had the graph f of x equals 1 over x minus 2. We all know what that looks like, hopefully. Maybe not actually, but that looks like this. If this is 2, then the graph looks like this. And it has what we call a vertical asymptote at x equals 2, right? You guys know what that means? No?
Touch it.
Sort of, yeah.
X minus 3, you put it on the x-axis.
X, sorry, what?
So when it says x minus 2, you just go to 2 to the right?
Yes, yeah. So yeah, right? If x equals 2, clearly this function doesn't work, right? Because you would be dividing by 0. And so it has what we call a vertical asymptote at x equals 2. I'll spell that for you. Vertical asymptote. An asymptote is just a line that the graph always approaches but never touches. Always approaching but never touches. Okay? So, if you were asked on the test, what is the limit of f of x as x approaches 2? What's the answer? Yes, very good. Doesn't exist. Why? Yeah, right. It doesn't approach any finite value as x approaches 2, so we would say it doesn't exist. Okay? That was the topic of our group quiz as well. Okay? But, you know, even though it doesn't exist, mathematicians still want to say something useful about it. And so people came up with this concept of infinite limit. And so for the function f of x equals 1 over x minus 2, we would actually say that the limit of 1 over x minus 2 as x approaches 2 from the right, so we write a 2 with the plus sign, right? This would actually, technically doesn't exist, but you can also say it's positive infinity, the limit as x approaches 2 from the right side. Okay, and why is that? That's because as we approach x from the right side, right, the function goes up to positive infinity. And so we would say the limit goes to positive infinity. On the other hand, from the left side, so x approaching 2 with the minus sign, tiny minus sign, that's going to be negative infinity. Right? And the reason for that is that because when we go from the left side, when we approach x equals 2 from the left side, the function descends to negative infinity, increasing, or sorry, in this case, decreasing without bound. Questions? So technically, the limit doesn't exist, but if we were to write infinite limits, this is how we would write them. Okay. On the other hand, because they approach different infinities from right and left side, there's nothing really useful we can write about the actual limit, so we would still probably write dne for that. Okay. So those are infinite limits. Pretty straightforward from the graph, certainly. Okay, I'll do another example, or I'll go with this slide. Yes. Let's say we had f of x equals 1 over x squared. The graph of this is a little different because in this case, they actually both approach positive infinity, both from the left and the right sides. So in this case, the graph actually looks like this. It's supposed to be symmetrical. Yeah, it never touches the y-axis, but it always approaches the y-axis. So the y-axis, or x equals 0 in this case, is the vertical asymptote. X equals 0, vertical asymptote. Right? But in this case, they both approach positive infinity from the right and the left side. So we would write the limit as x approaches 0 in this case from the left side of 1 over x squared is positive infinity. And it's also the same for the right side, right? The right-sided limit. So 0 plus, also positive infinity. So in this case, we would be able to write that the limit as x approaches 0 from both the left and the right sides is positive infinity, which is not something that we could write for the previous one.
Because it's different.
Yeah, because they approached different infinities. One was positive and one was negative. Questions? So you'll notice that these asymptotes, they all occurred when the denominator was equal to 0, right? So for example, in this case, the asymptote is at x equals 0, which is where the denominator is 0. And in the previous example, it was at x equals 2, right? Because that's where this denominator is 0. But that's not always the case. That's not always the case because some values of x are removable discontinuities. They're holes, right? Remember what we learned last time? So vertical asymptotes are always non-removable, right? Because they're not holes. They're enormous jumps. But some are removable, which means that they're holes and they're not vertical asymptotes, which would be best seen from an example. Huh? Yes, or yeah. So for example, let's do this one. Let's say you have a question that asks you, oh, you're given this function like x minus 1 over x squared plus 2x minus 3. Okay. And let's say this question asks you, find the vertical asymptote for this function. Find the vertical asymptote. Now, what you could do, and you'll be wrong, is you could just find the values of x that make the denominator equal to 0. But you would be wrong, because one of them is actually a removable discontinuity. It's a hole. So it's not a vertical asymptote. And I'll show you why. Well, yeah, when we factor the denominator, we actually get x minus 1 times x plus 3. And so actually, you know, we have two discontinuities, right? There are two values of x that cause the function not to work. So the function is discontinuous at 2 points. F of x is discontinuous at x equals 1 and negative 3, right? Because those cause the denominator to be equal to 0.
Is it if or is?
Is, yeah. So it's discontinuous at those 2 points, but only one of them is a vertical asymptote. Only x equals negative 3 is the vertical asymptote. The reason for that is because x minus 1 cancels out from the top and the bottom, right? So that's actually a hole. It's a removable discontinuity. X equals 1 is a removable discontinuity because it's something that we can get rid of by factoring and canceling. Removable discontinuity. So indeed, if we were to graph it, it would actually look something like this. There would be a hole at x equals 1, which is around here or something. And then there would be a vertical asymptote. Let me see. That's weird. Oh, negative 3, yeah. So it looked like this. Okay. So there are two discontinuities, but only one of them is a vertical asymptote. The other one is a hole. Okay. So don't get tricked by these questions. So to find the vertical asymptote, you first want to factor everything and then see what you can cancel out. And whatever you can't cancel out is going to be a vertical asymptote in the denominator. Questions? Next. Next thing is that you need to be able to determine whether it's positive or negative infinity without a graph, okay? So let's say we had f of x equals 1 over x minus 1. And let's say your question asks you, what is the limit as x approaches 1 from the left side of 1 over x minus 1? You know it's going to be some kind of infinity, right? Because that causes the denominator to be 0. But you don't know whether it's positive or negative, right? So that's what you need to figure out. What I recommend as a good strategy for doing that is by plugging in a value that's super close to 1, but on the left side, and then seeing whether it's positive or negative. Okay? So what I'm going to do is I'm going to plug in 0.99, because that's on the left side of 1, right? We draw it out. 1 is here, 0.99. On the right side will be 1.01. So I'm going to plug in 0.99 and just see what happens. I'm going to do it on the side because it's not actually equal to that. If I plug in 0.99, my denominator is going to be a negative number, right? It will be negative 0.01. And so, you know, that's a big number. It's a big negative number. This will be equal to negative 100. And so I know that as it gets close to 1 from the left side, it will be a negative number. So I'm going to write negative infinity. Okay? On the other hand, if I was asked x approaching 1 from the right side, I would plug in maybe something like 1.01. And 1.01 minus 1 is a positive number. It will be 1 over 0.01, positive, which would give me 100. So I know that as it goes to 1 from the right side, it'll be a big positive number. So I'll write positive infinity. Okay? Questions? So on Moodle, I've posted the chapter 1 study guide, which you should all be able to do now. You've gotten all the content for this chapter already. So I would recommend doing that. Study guide. Any final questions? So some things to note about the study guide are that question 22 is a little hard. And won't be on the test. But you can do it if you want. 23 is also a little hard. It won't be on the test. On the other hand, 24, you should do it. You should do it. And you know why I'm saying that. Like, almost word for word. It might be word for word. Haven't looked at both versions. Okay. Yeah. Okay, any questions about the test? Let me open it up from my side. And I can answer any questions that you have beyond like just telling you what the questions are. No questions? We're gonna get above 73% on the test?
I think we can come in tomorrow lunch.
Okay, yeah. Okay, the test has how many questions? 20 questions. 20 questions. I see questions about asking what the limit is based on a graph. I see questions about finding the vertical asymptote. I see one of those questions that it gives you a piecewise function. So something like this. F of x equals something here for x is less than, 3 or something. And something here if x is, make up some numbers. And it asks you find certain values such that this function is continuous. You guys know how to do those problems? You would have to plug in the values of the boundaries. So you would plug in x equals 3 and x equals 7, and then try to make sure that the function doesn't have any jumps at those points. So you would try to make sure that when you plug in x equals 3, then this equals this, and then when you plug in x equals 7, make sure that this equals this. And then it would be continuous. Those questions. I see a question that
You
you...
still have website too.
Huh?
You have
Oh yeah, web assignment for tonight's homework. I have questions about those trig limit identities, but they're not super hard. From my perspective, at least. Questions about infinite limits. Audrey?
So I thought that we were excused from the 1.3 homework journal because it didn't match the web assignment.
So for this unit's homework journal, basically, none of the questions that I gave matched the WebAssign. So that's why I allowed, I excused you guys from writing on the thing that I gave you. So for the homework journal, you have to do something else, like write on your own Notability thing, or write on your own notebook. Yeah. So you're still submitting a homework journal. It's just not going to be based on what I gave you guys. It'll be based on the actual WebAssign problems.
Some of the questions were just like looking at the graph.
So for those, you would not have to show work. Yeah. Any other questions? That's in.
So what if I did the the homework journal and then I looked at the website because I didn't know about the website was different. And then I just did the questions on the website as well.
Yeah.
But can I just leave it on, because I did the homework journal for all these ones. And then I just, on the ones on the next unit, I just like wrote over them. Would that be okay?
Yeah, that'll be fine. Yeah. Any other questions?